Good afternoon, everyone. Welcome back to our YouTube live session of webinar of Gen AI. Today, we're going to discuss a very interesting topic, which is agentic AI topic, which is Flowise AI, right? Let me explain you the architecture first. And before we get into the architecture, we'll try and understand what is agentic AI itself. Agentic AI refers to autonomous systems which are of multiple interacting agents. Agents are nothing but intelligent beings which are designed in order to collaborate and execute a very complex task. Any sort of complex task can be given to these agents. These agents will represent different types of functionalities. From querying knowledge bases to interfacing with external systems, it can do anything, right? The entire purpose of this creating agents and agentic AI in the first place is to actually automate support operations, accelerate root cause analysis, interact with multiple systems seamlessly. So all of these things can be done seamlessly. Okay, let's look at entry point, which is the customer support engineer in the first place, right? Who is at present at the data center location. So the flow begins with the customer support engineer who's actually managing the issues from a data center. When an incident arises, for example, server is down or there is any abnormal behavior with the server, this engineer, customer support engineer, sends a natural language query, an NLP query. For example, why is the server 52 rebooting every 15 minutes? He will send a natural language query like this. Then comes your enterprise collaboration platform with the bot. This NLP query is routed through an enterprise collaboration platform, for example, Slack or Microsoft Teams, along with an embedded AI bot. And this AI bot will process the query. It will recognize what is the intention and determine if escalation or further analysis is required. This bot does not work alone. It passes the query to the next layer for deeper understanding and some action to be taken place. Then comes your super agent, who's basically the central cognitive unit. The super agent will act as the main intelligent processing agent. Think of it as like a brain that will decide what data is needed, which systems should be queried, whether to invoke an AI model, whether to call APIs, or fetch any embeddings from the vector database. These kind of decisions is what the super agent cognitive unit is going to take. It is the main intelligent processing agent in the first place. It will receive the query through a secure WebSocket or an HTTPS channel, or rather an API key also. The key interactions of this super agent are, it will connect with the secrets encryption platform. It will connect with vector database. It will also connect as, it will have a connection as a service for the devices. So what happens is, it will connect with the secrets encryption platform for securely handling the credentials. It will also connect with vector database in order to store pre-computed embeddings, any logs, or any historical incidents in order to support for the semantic search or retrieval-based reasoning. Connection as a service for devices, basically all the bulk queries to edge or on-premise devices to pull system state or metrics in real time. That's why we need this connection. Then comes your orchestrator agent. The orchestrator agent will coordinate between the super agent and some AI models. Think of it like a middleware or some sort of a conductor or a bridge even. It knows when to use a cloud AI model versus a local Llama 3 model on NVIDIA A100 clusters. So when should I use Claude? When should I use a cloud AI versus Llama 3 versus embedding model, right? All of these things, it's going to take a decision. Or whether to pull the embedding vectors from a pre-trained local model in order to enhance the contextual understanding. Authentication, right? How does orchestrator agent actually communicate with all these models? Cloud AI model or Llama 3 endpoint by NVIDIA or embedding models. It communicates using HTTPS or APIs, and it will support both API key and non-authorized modes depending on the security level that you require. So let's discuss a real use case. If the support engineer asks for root cause analysis, the orchestrator might actually send logs to Llama 3 endpoint in order to analyze anomalous patterns or use the embedding model in order to search similar incidents. So for different purpose, it will go to the different model. If it has to look into, what kind of anomalies, what kind of patterns, what is this abnormality, why does it occur, any sort of pattern like that, then it will go to Llama 3 endpoint. Or if it wants to understand any similar incidents have taken place in the past, then it will go to the embedding model for search. Then comes the role of utility agents. These utility agents are interfacing with core systems. On the right side, we see a series of utility agents. There are many agents which each interfacing with a specific kind of a tool. First one is case and incident management systems. For example, ServiceNow, Jira. Then your monitoring systems, for example, Prometheus, Grafana. Then AI ops tools like automated root cause analysis or any sort of anomaly detection. Then NMS stands for Network Management System. This will track the health and performance of the network elements. Then comes your inventory management, data on which parts are available, okay, and what's exactly under repair, etc. All these things will be taken care of. Then you have DDoS protection system. This will interact with the firewalls, IDS or IPS, etc. Then we have log aggregation system, like for example, Splunk, ELK stack, etc. Then we have troubleshooting and visualization tools for dynamic dashboards or RCA visuals. These agents will basically fetch relevant data or trigger actions as instructed by this super agent. These multiple agents will perform that. Multiple utility agents. Then comes the security considerations that we need to talk about. Secrets encryption platform, right? This will ensure that no credentials are exposed, all your tokens, passwords, any API keys that you use. They're basically used to talk to external systems. They're all supposed to be securely stored and accessed. This will ensure compliance with data security standards. For example, SOC2, ISO 27001, 27001, all these things. And vector databases and semantic understanding. The vector database will actually allow semantic retrieval of historical logs, incidents, or embeddings. This will enable intelligent systems to understand the context and relate past cases to current problems, even if worded differently. For example, if the engineer types server crashing after database sync, then the super agent will fetch similar vector embedded incidents, even if earlier wordings were crash post data flush. So even though the terminology was completely different, it is still going to fetch the similar incidents. The super agent has this kind of a capability. The entire system will work like a multi-layered intelligent assistant where queries are handled naturally. Cognitive decisions are made through agent collaboration. Responses are powered by either AI plus RAG, which is retrieval augmented generation, and it will be actioned through APIs. The support engineer will get a fully contextual, real-time intelligent answer, improving the resolution time and reducing manual triage. What is the impact on business and what are the use cases of these kind of multiple agents, right? Or agentic AI even. The first one being faster troubleshooting. So reduces MTTR, that means reduces the mean time to resolution. Smarter automation because AI-powered RCA and self-healing is available. Reduced escalations because frontline support becomes more effective. Then improved knowledge retention because via vector databases and embedded recall of past issues. It will improve the knowledge retention. We have multiple use case examples for this. In retail industry, I can build a instant RCA when POS system crash, point of sale systems will crash. Manufacturing industry, you can give real-time alerts from IoT devices, analyzed and acted upon. In telecom industry, DDoS mitigation triggered automatically after an anomaly detection. Multiple use cases can be there. Finally, agentic AI isn't actually just about replacing the human tasks. It's about amplifying human intelligence with autonomous, interconnected agents that work together like a symphony, delivering very fast, smart, and secure decisions across different enterprises systems. Now we'll talk about Flowise AI. So Flowise AI is an open source drag and drop visual programming tool, which is built on top of the LangChain. We already discussed LangChain framework. It is built usually on top of this. Okay, it's an open source drag and drop visual programming tool. There is no code at all, right? No code kind of a tool that can be used. It is designed to help you build and deploy LLM-based workflows and applications without even writing heavy code. Think of it as the low-code or no-code platform for LLMs. Like how Power BI helps with data, Flowise will help with large language models. What are the key features of this Flowise AI? It's visual workflow builder. You get a flow chart like UI where you can drag nodes like ChatGPT, Chat OpenAI, prompt templates, tools, etc., and connect with them. Each node will represent a LangChain component, for example, a language model, a retriever, memory, or even a tool. Then we have the pre-built and custom components. Flowise has pre-built integrations for OpenAI, Cohere, Anthropic, then vector databases like Pinecone and ChromaDB, then custom API calls. You can also create your own nodes in TypeScript or JavaScript. Memory and retrieval augmented generation RAG. You can implement memory chains and RAG pipelines just by connecting an LLM with a vector database and lots of document loaders. What are the common use cases of this kind of tools like Flowise AI are? Customer support bots, combining FAQ documents with LLM in order to answer queries. Instant knowledge assistance, which will connect to Notion, SharePoint, or PDFs. Custom GPT like apps, building your own chatbot with custom behavior, using a prompt chain. Then you can also build data pipelines, create automation flows that involve fetching, transforming, and analyzing data with LLMs. Then finally comes deployment and integration. You can run Flowise locally on cloud or inside Docker. REST APIs are auto-generated for your workflows so that you can embed them in any app, like on React or Streamlit or webhooks. Great for startups, prototyping, or enterprising POCs, proof of concepts. Why it's gaining popularity? Basically, no deep coding needed at all. Rapid prototyping of LLM chains. Then we have built-in observability. You can see inputs, outputs in real time, and a lot of active community. And of course, because of the open source freedom, Flowise AI is really going to be a great tool for this. So stay tuned, guys. We will talk more about agentic AI, all the different agents. How do I start working on agentic AI? Again, we'll also get into a lot of different prompting techniques, different vector databases, a lot more exciting things that we will be discussing in this Gen AI webinar. So stay tuned on every Wednesday. Thank you so much. Thank you.